Good morning, everyone. Today we will take up a new aspect, that is the geological work of river. We have studied about weathering, and we have learned that there are two major types of weathering, that is the physical and the chemical weathering. The physical weathering, it breaks the rocks into smaller pieces, whereas the chemical action, it disintegrates and decomposes the rocks on the surface of the earth. Now, the weathering process, it takes place on the surface, and it is in situ, that is, it takes place in its own place. There is no removal of material involved in case of weathering. Now, this decomposed rock material, which is very weak, it interacts with several natural geological agents like water, which is precipitated, like the wind, the glaciers, etc. Now, these natural agents or the geological agents, they modify the physical features or the geomorphology or the outer appearance of the earth. And this has been taking place ever since the earth was born, and this keeps on changing. That is to say, the evolution of topography is a dynamic process. It is not static, it keeps on changing with time. Now, the rivers, what are rivers? Rivers are the water that flows from higher gradient to the lower gradient. So we have got rivers, we have got glaciers, we have got winds, oceans and lakes. These have been modifying the surface of earth. Now, if we look at this, you are all familiar with the hydrological cycle. We know that almost the oceans have around 97.2% of the whole water that is present in our earth. That means we have only 2.8% of fresh water that is present. Now, this ocean water, it gets evaporated, then this gets precipitated within the oceans as well as on the land, and when it precipitates on the land, it is either in the form of rain at the lower altitudes or snow at the higher altitude. Now, this precipitated water and the snow, it moves down the slopes and moves over the hills onto the plains, and finally it comes down again into the oceans. Some part of it gets infiltrated and it moves in the form of groundwater, and some of it is stored within the glaciers and the ice sheets. Around 2.15% of the water is stored in the glaciers and the ice sheets, and only 0.65% of the entire water budget, it is part of the atmosphere, rivers, lakes, etc., and is fresh water, and that sustains then almost entire life that is present on the earth, maybe plants or the animals. So this is to show you the distribution of water in the different segments. Now, the water that precipitates, it moves down under this action of gravity through various channels. These channels are initially smaller at the higher level, and as the water moves down, it increases the width, and the amount of water also keeps on increasing as the tributaries, they join together and come down, and from the hills the river comes down on the plains and then flows into the oceans. So in this diagram you can see that you have got, this is known as the water divide. So whatever is precipitating in this portion will move down in this direction. This will move down in this direction. This is entire drainage basin. That means that whatever rain has precipitated in this region will move down and it will reach at this point. So the moving water down the slopes, it has got a tremendous amount of energy. Now when the water is moving down, as I told, it has got a lot of energy. So this energy depends upon what is the slope over which it is moving, that is the gradient, and how much water is being discharged, how much is has precipitated, what is the discharge. So higher the gradient and discharge, more would be the energy. Now part of this energy is used in overcoming the resistance offered by the riverbed and the banks. So the water moves down. On the sides you have got the banks, and at the base you have got the riverbed. So the maximum velocity of water is in the top central part of the channel through which it is flowing. Now the water which is flowing, it develops different types of flows. These are termed as the laminar flow, the turbulent flow, or the helicoidal flow. Now in this diagram you can see this is the laminar flow where it is moving in a smooth pattern, and this is the turbulent flow. So as we can see that if you draw a cross section of the river channel, because of the resistance at the bed of the river, minimum velocity is here, and as one moves up, the maximum velocity is at the top. We will be discussing this linear and turbulent flow in next slide. Now in this two diagrams I tried to describe what is the laminar flow and what is the turbulent flow. So laminar flow, it means that the different layers of water move in parallel and regular pattern or regular path. And if we assume that this water is moving in this channel or say a pipe, the maximum velocity would be in the central part, as the sides would offer resistance to its movement. Now in case of turbulent flow, the different layers of water move in irregular colliding paths. They are not moving in parallel and regular path, but they keep on colliding and it is irregular. The water not only moves in the forward direction, but it can move in the upward and even the backward direction. So here the path of water flow are irregular, as different parts of the moving water mix together or form a smaller circular region that resemble whirlpools. I understand that most of you must be knowing what is a whirlpool or what is a swirling path. हिंदी में कहते हैं भंवर. Now this swirling path happens when the velocity of water moving in a channel reaches a certain critical velocity, and this can be commonly seen during the time of floods. If you have seen the river during the winter times and during the monsoon times, you can see that during the winter's time the same river would have a laminar flow where you will not find much disturbance, whereas during the monsoons, when the precipitation has taken place, the water becomes turbulent, and at times you have got the circular movement of the water that results in the formation of whirlpools. Now whether the flow within a channel would be laminar or turbulent, it depends upon a number of parameters that control the velocity of the water. Now velocity in turn, it is controlled by the slope or the gradient. So we have got maximum gradient in the hilly terrain. Then it also depends upon discharge. Now the discharge of a stream keeps on increasing as the stream moves down the slope, because a number of tributaries add water to it. Then it also depends on the channel shape and size, as well as the amount of sediment that is being carried by the river. That is known as the sediment load. What sediments, how much sediments it is carrying. So these are the parameters that decide whether the flow in a river would be laminar or turbulent. Naturally, why I am trying to explain this is because the laminar flow will not exert that much of force or energy on the channel through which it is passing in comparison to the turbulent flow. Now, here I have tried to explain the shape and size of the channel through which the water is flowing. Now we can take this channel here. The channel is very broad, and in this channel certain volume of water is flowing through, say, point A along the cross section of a river, that is A1. Now for this volume of water, it will take a certain time. So in certain time this volume of water will pass through point A. Now if we move ahead and the channel becomes narrower, now when the channel becomes narrow, the same volume of water has to pass through this channel, and hence the length of this volume would increase. That is, the velocity of the water will have to be increased in case it has to carry the same volume of water through that fixed particular time, because time of travel is the same for this place and this place. Now in order to carry this volume through a narrow channel, the river has no option but to increase the velocity. So here in this place the flow would be laminar, but when the channel becomes narrower and the velocity increases, the energy increases, the water becomes turbulent as compared to this place where the valley is wider. Same is being shown in this diagram. Here this is a wider valley. Now as channel, it's a channel, so as this channel is broad, here it would be laminar, but as this narrows down, the water becomes turbulent, and hence whatever comes its way, it will try to remove or exert enormous force. This is the plan and cross-sectional profile of a river right from the point from where it is starting. These are the points from where the river is starting, smaller channels, and they join together. So smaller channels will join together, and as this moves down the slope, the amount of water will keep on increasing, and even the width of this channel keeps on increasing. So you can see that this is point A. Here a cross section has been made across this channel, and the cross section will appear something like this. Now at this point B, where the valley becomes more wide, the shape becomes like this, and from this point it is the hilly region, and here it comes onto the plains where it will have different morphology that we'll be discussing, and at this point the channel becomes very, very wide. So right from this A1 point, so you have the gradient is very high as it comes down. So here beyond this point 3, and here this is the point where it enters the plains, and then gradually this gradient keeps on decreasing, and here this meets the sea, where you have got the formation of the delta, and this is known as the mouth of the. So during its journey from the hills to the sea, that is from the highest of the elevations up to the sea level, the energy of the flowing water within the channel keeps on changing, and accordingly the river carries out erosion, transportation, and deposition. Now, whether there would be erosion, or the sediments would only be transported, or they would be deposited, it depends upon the energy of the river. As discussed earlier, the energy of the flowing water depends upon the slope, which is maximum in the hilly terrain, amount of water, which keeps on increasing as the river moves down the slope, because a number of tributaries keep on adding to the main or the trunk stream. Then the width of the channel, here it is very narrow. This keeps on broadening as it comes down in the plains, and in the plains the channel becomes wider and wider, and near the sea it is almost the widest. Then it also depends on the surface roughness, this we discussed earlier, and the amount and the type of sediment load which is being transported, that we will be discussing now. Now, while the river is flowing in the channel, the velocity is very important, and within the channel there is a velocity distribution across the channel. Like if we have a stream which is flowing along a straight course, now when it is flowing along the straight course, there is resistance offered by the base of the channel as well as by the margins, as a result of which the maximum velocity is in the top central part. So here you can see that this is the region which is having the maximum velocity, and this keeps on decreasing as we move towards the margins and the floor of the channel. However, in case the river is curved, the channel is curved, such a pattern is known as the meandering pattern. And now in this if you see that part of this, it is a straight channel, so here the maximum velocity would be in the central region. Now when the river turns, then the minimum velocity would be towards the inner side, and the maximum velocity would be towards the outer side. This we can see when we are moving on our bike on a road, and if suddenly there is a turn, then one has to slow down in order to cope up with the turn. Or if we want to maintain the same speed, then if we want to do not want to reduce our speed, then we have to take a larger turnaround adopting a longer distance. So when the river bends, here we can see that on the outer side, in order to carry the same amount of water, it adopts it increases the velocity, and on this side there is relatively decrease in the velocity. Similar is the pattern here, where there is lesser velocity towards the inner side and more velocity towards the outer side. As a result, this maximum velocity, it is concentrated in this part. This is the sectional view. Here in this portion it is towards the central part, and here it is towards the left hand side, and accordingly the river is deepened in this part, because the velocity energy is higher here, so it is the depth is more, and here the depth is more on this side. So then on relatively, since the velocity is lesser on this side, so there would be the deposition of sediments both this side and here on this side the banks are eroded or they are cut down. So when the channel path bends, then the maximum velocity does not maintain a straight course. Maximum velocity is then concentrated towards the outer side of the bend. Here this is another diagram that explains, because it is the path is curved, so the water is not moving in a laminar pattern, rather it becomes more turbulent towards the outer side. Now this is a cross section prepared along the river channel. Here this is the has the maximum elevation, and here this is the river meeting the sea. We can see that there is a change in the gradient. Right from steeper it becomes gentler and gentler as it moves towards the sea. And if we make a cross section across the channel, here as we discussed earlier, it is very narrow, or it is V shaped, and here at this point Y, the channel is very broad with the development of floodplains that we'll be discussing. So this is the normal stream which is flowing. However, during the time of floods, the river occupies a wider plain. However, in this region, even if the amount of water is high, it does not make any flood plain, because here it will keep on flowing in this channel with a higher velocity. So you have naturally this has got higher velocity, the energy is high, so this zone is more prone to, or rather most prone to, erosion. This is the in between, you have the transitional zone, and in this part, since the energy keeps on reducing because of the lowering of the gradient, so most of the sediments get deposited in this part. So we can say you have the erosional zone, transitional zone, and the zone of deposition. This is again the same thing. We try to explain it with another diagram. Here this is the starting point of the river. A number of small rivulets, they join together to form a main river, and in the upper course we have defined here a number of parameters, how they change as the river moves from higher elevation to the lower elevation. Like the gradient, it is highest in the upper course, and as it comes down it reduces. Similarly, roughness of the channel bed, since it has got more of energy, there is more of erosion, and hence the bed of the channel is not smooth. It is always rough, filled with boulders. Large boulders are there. Most of you, if you have been to a hilly terrain, you must have seen that the rivers, they carry a lot of larger boulders. So this has, as a result, the roughness is very poor, more rough. However, if you come down to the plains, like you visit, if we say talk about river Ganga, then if you go up higher up towards the Gangotri side, come down towards the, here you can say you have the Rishikesh, Haridwar, and then you have the Kanpur, Varanasi. There the size of the sediments is very small, and so accordingly the roughness of the channel would be smoother as compared to the roughness in the upper course. Similarly, the elevation of the channel bed, it keeps on decreasing. The slope of the channel bed, it also keeps on decreasing. The load, that means the sediments it is carrying, the size, it also keeps on decreasing. Here the sediments, as I told, would be having larger dimensions, and as they move down, the dimensions or the size keeps on reducing depending on the energy levels. So similarly, energy, it also keeps on decreasing the coarser sediments to finer sediments. However, since a number of streams are joining together, tributaries are joining together, the discharge as compared to this point and as to this point, it keeps on increasing many folds, and as we discussed, the channel width also keeps on increasing, the water depth also increases, the velocity of water also increases, because the velocity of the water is not only controlled by the gradient, but it also is controlled by the amount of water that is flowing through the channel. So the water velocity and the total load, the total sediments, because the sediments are brought out from all the tributaries of the basin, so the amount of sediment load is, of course the size is smaller, however the total amount of load keeps on increasing as we move towards the sea. Now there is a term base level. Base level is the level up to which a river can erode its channel, or below which the water will not erode the channel. So the stream of water cannot cut deeper than its base level. Now if we are at the highest elevations, so this was, say, earlier the altitude of the river. Now it keeps on eroding its base, and if there's a lake in between, it prevents the energy, the water when it enters, and it slows down, and then when it again moves down, the energy keeps on increasing. However, in due course of time, this area is eroded, and ultimately this is the level up till which the base of the valley is eroded. So that is the original profile, and this becomes the profile formed because of the erosion due to the flowing water. So now this is the base level. That means the water, it cannot be eroded below this point, and base level, it is defined as the lowest level to which the running water can flow and erode. So there are two types of base levels. One is the local base level, which is caused because of the presence of this water body or the lake, and then you have got the permanent base level, which is this one. And the sea, the erosion of the valley floor cannot be below the sea level. So sea level is known as the ultimate base level, below which the river cannot erode. Now there are different processes of erosion. So erosion means the removal of the material from its place. So these are hydraulic action, solution, abrasion, attrition, and cavitation. Now hydraulic action refers to the ability of the flowing water to pick up and move rock and sediments. Now if we have precipitation, you must have seen that when the water moves down the slope, it carries along with it a number of sediments, whatever material is there, because it has got energy, so it will carry them along with it while it is flowing on the surface of the water. So it will pick up whatever comes, and depending on the energy that it has. Then another is solution. Solution we had also discussed in withering, but when solution was considered in withering, that was in situ. That means it at its own place. While in erosion, the material is carried from its own place. So the flowing water, it dissolves a number of uh, a lot of material, like you have a limestone terrain, and because of the action of water with the limestone, calcium carbonate is dissolved and it moves in solution. Now there is another process that is known as abrasion. Abrasion, I think you must all be familiar with a number of abrasives which are used in our daily life, like the normal rubber you use for removing the what you have written with the help of pencil, eraser. So that eraser is an abrasive. Sandpaper, regmal, that is another abrasive by which we remove the say the uppermost paint or smooth, that is used for smoothing the surface. Now you must also be knowing that these sandpapers, they are coming in different numbers, and the number depends on the size of the grains that are present on the surface of the sandpaper. The black sandpaper, it has got coarser sediments or coarser particles which are used for rubbing, and whereas fine there are sandpapers which are got with, they are used for smoothing the surface of the material over which they are rubbed. Similarly, the nail cutters, in the nail cutters you also find some abrasive by which the nails are smoothed. There is a rough surface and that smoothens the nails. Similarly, रेती जिसको हम कहते हैं, रेती means the file. So that file is used to polish or to smoothen the rough surfaces. So abrasion is a process of erosion which happens when the material being transported, it wears away or it breaks away at the surface over time. So rough surfaces are broken down and the surface becomes smoothened. It is the process of friction caused by scuffing, scratching and rubbing off away of the material. Now the intensity of abrasion depends on the hardness of the material which is used as an abrasive, like as I told you in case of sandpaper, how concentrated the effort is, for how much time the abrasion is going on, how much energy is there, and what is the mass of the moving particles. Now in case of rivers, the sediments which are carried along with the river, they strike the valley's floor as well as the sides of the valley in the higher rocky terrain, and because of this impact, the valley floor as well as the sides, they get striated, they get smoothened depending on the size of the particles of the sediments which are striking the surface. Similarly, those particles which are striking, they also get smoothened. Now you can see in this diagram that the pebbles and the cobbles, they also become very smooth, rounded, because when they are traveling from higher altitude, the rough surfaces, they get broken down and they attain a spheroidal or a spherical shape with the surfaces very smoothened. And such type of boulders or cobbles and pebbles you can get a lot in foothill areas, like if you have been to Haldwani, or if you have been to Kathgodam or Rishikesh, Haridwar, you can find a lot of such pebbles and cobbles which have rounded. Now this rounding or the smoothing of the surface is because of the process of abrasion. The sediments being carried by the river water are constantly bombarded. As a result of the even the floor of the valley channel and the sides, they get smoothened. Now depending on their size, they may get ribbed or they may get striations, and smoothing also takes place depending on the size. So there is another process of erosion, that is attrition, where the coarser sediments that are being transported downstream along a riverbed, they regularly collide amongst each other. They are not colliding with the floor of the valley, but they collide with each other, and now their regular impact makes them smaller and smaller, and those larger boulders, they are gradually broken into smaller fragments. So the striking of the grains amongst themselves results in becoming smaller and smaller, and such a process is known as attrition. And there is another process of erosion that is known as cavitation. This occurs near the waterfalls. Now what happens when the water is falling along a waterfall? Then along with this water, a lot of air is trapped within these the water, and this trapped air, it moves down the water which is filled at the base of the waterfall, and they travel deep inside, and when these bubbles, they touch the floor of the rock, they explode, and when they explode, they release a large amount of energy. It's just like a hammering of the already weathered surface, and that results in the erosion or the removal of the material. So these were the different processes involved in erosion. Now we'll discuss some of the landforms that are caused due to the erosion of river, by erosion by river. Now river system is also known as fluvial system. The river system is also known as fluvial system, just like we'll also discuss when the erosion or the geological work is done by wind, that is known as aeolian system. So we are going to discuss the landforms formed by fluvial system. Now the first and the foremost, or the important geomorphic feature formed because of the fluvial erosion, are the V-shaped valleys. Now what happens in the hilly terrain, as we discussed, the gradient is very high, so the energy of the flowing water is very high. Now this flowing water carries along with it a large amount of sediments. Now these sediments, they, because of their higher density and weight, they travel all along the floor of the valley, and when they travel along the floor of the valley, they act as tools and cut the valley vertically downwards. It acts like a saw, आरा जिसको कहते हैं, आरे की तरह, आरे से वो उसको जैसे कि हम लकड़ी काटते हैं, उसी तरीके से this flowing water, having tremendous amount of energy and carrying these sediments, they cut the valley vertically down, and relatively the lateral cutting is absent or very little, insignificant as compared to the vertical cutting. So as a result, the valley becomes V-shaped. You can see that the valley is V-shaped in nature. Here I have tried to give 3 examples. You can see that the valley is, and since this is in the hilly region, you can see that the amount of water is not very large, the discharge is not very large, but the energy is extremely high. As a result of it, there is vertical cutting. Now, under extreme conditions or under the favorable conditions, this V-shaped valley could be converted into vertical gorges, or they are also known as canyons. Here, this is the example of uh, this river coming from the Himalayan region, where you have got a narrow gorge which has formed. Now, this is under favorable conditions. Now, what could be those favorable conditions? The favorable conditions could be that there could be some weak plane along at this place, and because of the weak plane that are present in the rocks, the river has been able to cut the has been able to cut it vertically up vertically. Similarly, this is another example where you can see that the river, which is flowing with extremely high energy, it has cut the rocks vertically, and the valley is very narrow. So it is a very narrow V-shaped valley, or rather a vertical cutting is there. Similarly, this is a river that flows deep inside, and this is from the Kutch region, where you can see that earlier it was flowing at this level. Gradually, because of the favorable conditions, it has incised, or it has cut this valley vertically downwards. So it could be because of the extremely high energy conditions, it could be because of the presence of weak plains, or it could be because of the poor lithology or poor rock type. If there are some rock types which are very prone to erosion, then you can have these gorges and canyons. Another type of landform are the waterfalls and the rapids. Waterfalls means there's a sudden break in slope and there's vertical movement. Now, when I was talking about this, the process of erosion, then we had discussed that in the along the waterfalls there's cavitation. So when the water is falling like this, you have got water and the air trapped in this, and the air, when it is touches this floor of the bottom of this valley, it explodes. So there the cavitation takes place. So you have got waterfalls. Then rapids means if there is a rock which is more resistant, it does not erode just like the other surrounding rocks, then there is a sudden change in the gradient because of the presence of, so these are known as gradient, the rapids. And because of this rapid, here the water is very very turbulent. Now these are the famous Dhuandhar Falls in the Jabalpur area, and these are the Jog Falls of the Karnataka, and this is another waterfall in the Himalayan region. So we can see that these are very picturesque landforms that are present in the rocky terrain, and the extremely high energy conditions are there. Now this is another very significant landform which is seen. These are known as the potholes. Here we can see that you have got cylindrical holes. So now because of this abrasion, what happens when the energy is high, the water, as I told you, not only moves in the forward direction, but it also moves in a circular pattern. Now, and you have got the eddies and the swirls, bhamar aa jati hai. Now when there is a circular movement of water, these smaller pieces of rocks, are known as the cobbles and pebbles, they are caught up within these circular motion, and they grind the this rock at the base of the valley. And because of this grinding effect, a number of by these tools, there is a circular depression that is made on the valley floor, and these are known as the potholes. And you can see here that it is almost like somebody has drilled it, Similarly, you can see a number of potholes. Here also earlier a number of potholes were present, but the river has cut down and you can see half cut potholes present on the sides. So these potholes are typical features where when the energy, it is not necessary that the energy of the river is the same this time. It has decreased due to certain reasons, but at the time it was formed, it is the energy was high. Or even here during the time of floods, the energy could be high, and that can result in further excavation of these potholes. So this is the mechanism of formation of potholes, where you have got the swirling movement of the water, and they are caught up as the tools, and they dig it inside the rock. Then another feature is the escarpment. Escarpment is nothing but a steep slope or a long cliff that forms as a result of erosion or faulting. Faulting is a process which you will be learning in structural geology. That is the offsetting of the beds. So, as a result of faulting or erosion, we have vertical steep slopes, and that they are known as escarpments. So these are the escarpments in the Deccan Basalt province in the western Himalayan region. Similarly, because of erosion on the relatively softer materials, closely spaced microchannels are developed on the hill slopes. They are common in sparsely vegetated drylands where the intense rainfall occurs at regular intervals. So, because of the rainfall, the surface, you can see these are known as the rills, very fine, narrow channels that are gradually developing, and these develop into further get modified into gullies. And then another landform which we encounter, they are the cuestas. Cuesta is a ridge with a gentle slope on one side, so we have got this gentle slope on this side and a steep slope on this side. Now this is observed in places where this rock, you can see this is inclined towards this side, and the inclination is not very steep, and here the slopes develop along the dip of the beds, and so these are known as dip slopes. So dip slopes are gentle, and towards this side this material which was lying below it, vertically below it, is not that resistant, is not that strong, so it gets eroded. So because of this erosion, the slopes here on this side are steeper and it is a softer layer, and the cuestas form along the low inclined dip slopes of the rock. So this is cuesta, whereas in case of hogback, this the inclination of the dip slope is also very high, and the slopes on the side, they are also very high. So hogback is again a narrow ridge or a series of hills with narrow crest and steep slopes of nearly equal inclination on both the sides. In this case cuesta, the inclination is low on one side, steeper on another side. In case of hogback, the inclination is steep on both the sides. So these are some of the prominent landforms that are observed if we look at the geomorphic setup of the area which is modified by the river system. Then we have got another features like the Mesa, Butte. Now the Mesa and Butte, Mesa is an isolated elevated land with a flat top and bounded by steep escarpments, thus displaying a characteristic tabletop shape. So you can see it just looks like as if it is a table. The surface is flat, and with the margins they are very steeply inclined or by the marked by the presence of vertical escarpments. Similarly, Butte, it is an isolated hill with steep, often vertical sides and a small relative flat top. It is smaller than Mesa. So this is smaller than the Mesa. And flat top plateaus are specifically known as tablelands. So this flat top plateaus, they also are referred to as tablelands. Then one very important feature caused because of erosion, subsequent erosion. It is not the erosion is not at the first instance. First of all, there is deposition of sediments, and because of the changing tectonic conditions or because of the change in the climatic conditions, the river which is flowing, it cuts through its own deposits. Now you can see here that this deposit, it was formed by the deposition made by the river which is like coming from here. Now then there is another there, a river which is growing like this. Now this deposit, it has been cut down vertically by a river which is flowing along this channel. Now these deposits, that means the river was once flowing at this level, but it has vertically cut down because of certain conditions that we'll be discussing later on. So such places are known as terraces. Similarly, you can see this is the Gola river coming down from Nainital at the Kargodam. You can see this yourself. So this is the floodplain that is made by the river, this region. Now because of certain changing conditions, because of the upliftment of the Himalayan mountains, this river has cut through its own floodplain. So now this becomes a terrace. I think you must be aware of what is terrace in your house, जिसको हिंदी में छज्जा कहते हैं. So this, if you stand on this terrace, you can look down vertically. Again, this is the closer sectional view of the terrace. So even if there are times of floods, the river amount of water will increase, but since it has been cut down vertically, the river water or the water level is not able to reach even up to this level, the older floodplain of the river. So these were some of the features regarding the erosion by the river system, and on next turn we will be taking up the transportation and deposition by river. But one thing one has to keep in mind, whether there would be erosion, transportation or deposition, it depends on the energy of the river. If energy is more, there would be erosion. As and where there is more energy, there is erosion, and if there is lesser amount of energy, then there is deposition of the sediments. So thank you, and we'll continue with our lecture in the second part.